Welcome to this video on ABB Drivesize. Today I'm going to cover examples and ideas for use in the HVACR industry. Just to introduce myself, my name is Scott Birchall. I'm the HVACR Global Region Application Engineer for Europe. So let's take a quick look through the agenda for today's video. So we're going to cover where to find the tool and access to it. There's a couple of different areas you can find it. There's an online and a downloadable version. What can Drivesize be used for? So what is this tool used for? What are the functions? Drivesize introduction. So basically I'm going to show you around the tool and just familiarize yourself with the layout. Then we're going to cover ambient conditions entry. It's important that you put this in on the drive sizing. Network details. So this is where we're going to enter details of the network, of the supply and things like that. And this will vary from country to country. So you may need some local information for that part. I'm going to show you how to add in the motors and select the motors. And then we're going to move on to sizing the drive based off the back of the motor details. And then from there, also one level up, sizing the transformer as well. Another thing I'm going to cover is a harmonics comparison to show you the difference and the impact on the transformer sizing that using 6-pulse drives compared to ULH, for example, would have. So this is a good one to put forward a comparison for a consultant, for example. And then a summary just to go through everything that we've covered. So where can we find Drivesize and how do we access it? So where do we find Drivesize and how to access it? So the online version you can find at this address at the top there, drivesize.abb-drives.com. There's also a version in the ABB library which you can download and install to your PC if you've got a login to that library. I prefer the online version because it's constantly updated. So if it's something new's released, it will be implemented into the tool and updated. Whereas if you've got a version installed to your PC and you don't have the updated version, there may be some things missing or some updates that have been made that you've not got in your version. And the online version is open access as well, so you can send this link to customers who can see this as well and use it. So it's easily shareable. So just to follow up on the last slide, this is where you can find the actual download for the PC version. So as you can see on the left there, the link to the actual download. So you can download this and install it. You will need administrator rights for your PC. So it's something you may need to put a ticket in for. So if you prefer that option, there is that as well. So what can Drivesize be used for? So what can Drivesize be used for? Just a quick overview of the functions. So selecting optimal drive system components, which is the line supply unit, the drive, the motor, or the transformer. Now, you don't have to go all the way to transformer. In the past, I've used this just for selecting a motor and sizing the drive, for example. It all depends on what you want to use it for and what the, I suppose, what the opportunity is you're working on. You can also use it to calculate system harmonics, efficiencies and power losses, inverter load currents, and the load of the supply unit. So there's a few different things you can do. We're going to cover a lot of these today that are relevant to HVACR and where I see would use them the most. On the right is a couple of pictures just to give you a flavour of some of the screens that we're going to see, with a selection in the top right there, and then on the bottom there's a harmonics calculation as well. So next, the Drivesize introduction. So an introduction to Drivesize tool and where everything is in the layout. So on the initial screen, as you hit the web page, this is what you've been met with. So you've got multiple options on there. You've got industrial drives, multi-drives, general purpose, drives for HVAC and water, machinery drives. There's all different options for different applications and product ranges, depending on what you're working on. Obviously, we're going to be looking at drives for HVAC and water considering this is a HVACR video. So if you click into that, this then gives you the initial screen of selection. So on the right hand side, you've got your system tree, where it'll have the motor option, drive and transformer, which you can, once you fill in, you can make selections on these. Across the middle is where you can fill in the information. So if you click on each one, it'll show you the different options for information you've got to fill in, including network data, drive and motor. So that's the basics. You've got the file menu where you can create new projects, open old ones, or save this one, for example. You've got all the usual options in terms of edit and copy and pasting, data, tools. So some of the things that are available across the top are also available in the drop-down menu. So Ambient, which we're going to touch on in the next part, where we put that in, duty cycle. So you can enter your duty cycle as well for your application if you know that, if it's something that's really intricate. Select, so this is what we're going to use when we put in the data. You press select and you can get it to select your motor, drive or transformer. If you press select all, that will actually select everything in the network. So for example, if you put your motor details in here, it will then select the drive, then it'll also select the transformer based on what you've entered. You can also enter multiple drives in this tree as well, multiple motors, if you want to build up a network. List will actually give you a list of options in terms of the details of what's selected, so if you want to do a report on that. And some of the other options will become available as we go through this video. Ambient conditions, and where do we enter these on Drivesize? So once you are through the initial screen and you've selected through to drives for HVAC and water, and you're ready to do the selection, the first thing we want to look at is ambient conditions. And as you can see in the tab across the top, there's a button for ambient. So if you click this, it'll open up. The default is set to altitude of 1,000 meters and temperatures for the motor, inverter supply unit and transformer at 40 degrees, which is fine in most cases, but in some areas you may need to change this, or there may be specific requirements for a project to change this. It's important to set these if there is something specific that needs to go in there, because it will affect the D rating on some of the selections. So it's very important to select that if there is a need to. If not, you can leave this as it is, but point to note right at the start. So network details in Drivesize and where to enter those. So now we're going to look at entering the network details, top level. So as you're on the initial selection screen, usually it defaults to starting at the motor. If I'm doing a full selection, what I like to do is go to the network data at the top and set this. So you've got frequency, for example, 50 or 60, depending where you are. And then you can set the primary voltage. So for example, I know in the UK it's usually 11 kV or 33 kV, and 11 kV is usually 100 MVA short circuit power. So that's what we're going to set on this one. The other option is 33 kV, which would be 200 MVA for the short circuit MVA. So it just depends on where you are, what the size is, and all that kind of thing. If you don't know this, at this stage it's not that vital. If you're only selecting the motor and drive, for example, you don't have to fill this in. But for this example, what I'm going to use to try and show you the full scope of Drivesize, it's good practice to put this in at the start. So let's look at adding in the motors. So next up, we're going to enter the motor details. So we're going to start this off with a single motor for a selection to make it simple, and we're going to build it up. So if you're on the bottom rung of the system on the left, which says undefined, this is what you should be met with: motor load and specifications. So you can select your load type there, so pump stroke fan load, or you can change the refrigeration stroke chiller. Naturally, these options will be different if you're in a different part of drive size with different drive range. We're going to leave this as pump and fan load for now. So overload type, you've got three types. Simple cyclic is the one that is selected as default and the one that we'll be keeping. So this just continues forever, and it repeats itself while, as long as the motor and drive are thermally stable, it'll continue to use that overload type. You got multiform cyclic, which is, it has multiple definitions in sequence, and it repeats them where both motor and drive are thermally stable, so it might have up to a maximum of 10. So if the motor has X amount of overloads, then the multiform overloads for the drive will have the same amount. Again, it's not something I'd see in HVAC that often, maybe in some other industrial applications. And you've also got one time at start. I don't see many applications either where you use anything apart from simple cyclic in HVAC. Then we've got, further down, we've got the speeds. You can set the speed of the motor power rating. So for this one, we're going to set 90 kilowatt as our motor size. And you've also got the overload percentage. So this depends on obviously the type of application. Leaving it at 100 is fine for a pump or fan. If you're doing a constant torque application, for example, you'd probably put that to 150 for something like a crusher or something industrial. And the overload percentage can vary as well, depending on country, but mostly it just depends on the application. So we leave that as 100. And what you can do, you can also go through more motor details in specifics like frame material, family, pole, and all that kind of stuff. What I like to do at this stage though is at the top just press select, and then what Drivesize will do is it will actually make a selection just based on this data that you've got. And on the right hand side it will give you a selection of a motor there, as you can see, M3BP280. So it's got the voltage, frequency, power, poles, and all that kind of stuff, and all the details there for the selection, which is fine. Obviously, you can change some of these if you've got some specific requirements. In this case, it's just an example. And then as you scroll down, you'll see the selection data in terms of margins, and it'll give you the graph as well in that respect. So you can also click into manual selection, which is quite interesting. It will show you the selection of the motor that has been selected. You can also manually select something different if maybe you want some more leeway, some bigger margin on the continuous operation or the max current. So you can change them up and down, or maybe you want a different type of motor. There's a specific type of motor you're looking for that's you want to select. So you can look through. This has got a lot of different things listed. So our next step is sizing the drive. So next, after selecting this motor, we're going to now select the drive. So if you go from the motor screen, which we had initially, if you go on the left side, click the next rung up, it should show drive, load and specifications page. Now you can set some specific currents if you know those, but at this stage I generally just pick select at the top there, and it will come and give you a selection. So it's given us a selection with 90 kilowatt drive, the nominal current of 169. It's also got the efficiency and losses there as well. It gives you the different selection data. And the thing across the bottom, it tells you what it's selected on. So selection method on this is IGBT temperature, because this is the thing that will be closest to the margin of the next drive. So you can also open the graph to see the different items that it's sized the drive on as well. So you've got the continuous loadability and the max loadability, so that's including overload. So that just gives you an overview of what selection you've made. From that, you can obviously change switching frequency if there's something which will derate the drive as well. So for example, if we go to 8 kilohertz and select, you can see the drivers increased in size. So in this case, we're not going to have any derate. We're just going to go standard. But that just gives you an example of the tool actually derating based on selections. Last step in the process is sizing the transformer. So after we size the drive, as you can see there with the details, we're going to step up to the top level and select the transformer. So we've got the details that we put in earlier for the network. And then if we now press select, it will select a transformer based on that. So 160 kVA transformer and some of the different details there. So pretty easy to do. Now you're probably thinking why you're not often going to select a transformer as a drives person or a motors person, for example. And this is just looking at the overall project, and we're going to use this as a good example in the end to show the difference between the drive selection in terms of 6 pulse versus ULH and the difference this makes on the transformer. So it's quite useful in that respect. And at the bottom, you've got the selection data there. And you can see a little insight into what we're going to touch upon later. The multiplier due to harmonics and obviously required apparent power. So some of the details there, and we're going to dive into those a little bit more. So next step, we're going to build out a project. So now we're going to build up a project. And to do this, we can click into Drivesize loading page and go to HVAC and water as we did before. So on the left hand side as we had before, this time we're going to add in some extra rungs for some of the drives that we're going to add in. So for this one, I've got 4 different sizes of drives that I'm going to add, drives and motors that I'm going to add in. So just like that, I'm going to adjust the network settings as they were before. So the first one I'm going to set is a 315 kilowatt motor. Press select. So this would be something like a chiller or something like that. So I'm going to base this on loosely on a data center project, so we can give a good example on the harmonic comparison as well once we change things around a little. So the next one size I'm going to do is 90 kilowatt. So again, 90 in there and select. This is for some pumps for CDUs, for example. So be a few of those usually range from 75 into up to 100 and something kilowatt that I've seen recently. And then we're going to add in some fan loads as well. So we're going to add in some 22 kilowatt fans. Select that. Then the last one, we're going to add some more smaller fans, some 7.5 kilowatt. So these are the sizes of motors that we've put in. These are selections made. Obviously, as I mentioned earlier, you can use existing induction motor or whatever you want as well. But these are the selections based on sizes. Now, what we're going to do now is we're going to size the drive for each one. So if we go to, we can actually press select all. This will give you a good demonstration of what select all. Now, what select all does is anything that's undefined, it selects everything left in the system tree. So because we've left everything as standard, it selected all 6 pulse options for all the actual drives that are left for each one. As you can see as we go through these, it's also selected the transformer. So based on that, we've got a 630 kVA transformer. Now, one thing you've got to do if you're changing quantities, is one thing to note, which I mentioned earlier as well, is that you need to change quantity on the drive. So for example, if we've got 2 chillers at 315 kilowatt, change the drives to 2. Now what happens is if you change the motor quantity on this rung, that'll mean you'll have multiple motors connected to that one drive. So for example, if I put 2 motors there, it would size that drive based on 253, 2 times 315 kilowatt motor. So we don't want to do that. So in each of the drive one, we need to put the quantities in of what we have. So for this, we've got 30, and then just click OK as you go down. That's fine. And then for the 22 kilowatts, we've got 20 of those. And then for the small ones, we've got 60. So as you can see, as you do that, it all becomes undefined on the drive because the drive selection is going to change. Now, all this means we've got 60 drives in this, for example, with one of these motors connected to each, is the way you've got to look at it. So once we've done that, we can click select all. We should see everything get resized based on that. So you just want to check the drive is still the same. So the drive is still 7.5 kilowatt, and all these drive sizes are the same, but there's multiples. Now what you will notice is the transformer will have changed from the initial one. So you've now got a 6,200 kVA transformer. And what's interesting is the bottom where we've got the selection data. This shows you the fundamental power, and it shows you the required apparent power, so including harmonics, and then it shows you the multiplier due to harmonics. So for sizing the transformer, so that's based on these numbers, so 0.79. So that's where it comes to 5704, which means you need 6,200 kVA transformer because of transformer sizes. That's the nearest one. So that's the initial setup for just putting together a short project. We're going to do some changes on the next section in terms of drive selection and what that looks like with the transformer sizing. So next I'm going to show you the effect of harmonics. So now we're going to look into the effect of harmonics on the sizing of the transformer and parts within the system. So if we scroll down the bottom of the initial selection, we've got the data which we discussed, and you can see the multiplier due to harmonics is 0.79, so it's a 21% D rate due to the apparent power required. If you click the button at the top and press network check, when you select it on the transformer and click calculate, this gives you the values, the harmonic values estimated for, calculated for that actual system that we've got. So as you can see, look around 23% current and 6 point something percent voltage. So that's higher than what you would want on a system like this. And for example, if you're looking at IEEE 519 and the tables within that standard, you'd be looking at 15% maximum on the current and 5% on voltage. So it's over that, and it'd probably be over on quite a few different standards as well, depending on where you are based and what standard you're working to. So if we go off that, so what we're going to do, we're going to change some of the drives to add some harmonic mitigation and see what effect that has on the sizing of the transformer and some of the numbers. So we're going to start at the top with the largest loads. So the largest loads, the chillers at 315 kilowatt. There's two of these. So what we're going to do is click into the drive and then change those to low harmonic and press OK. As you can see, it goes to undefined because these need to be reselected. So from that point, we just press select all and the software then reselects based on the changes we've made. So now if we look at the transformer, as you can see, things have changed. The multiplier has changed to 0.82, so slightly less D-rate, only 18%. We've also come down the size of the transformer as well, from 6,200 kVA to 5,700. So you can see that's initial cost saving straight away. The fact that they can reduce the transformer and also reducing the harmonic level as well by changing the drives. If we also click the network check and click calculate, you can see the numbers have reduced a little bit as well. There's a slight change compared to what they were, so that's an improvement. It's still not at the level you would expect, but we can change some more and see what happens. So if we go to the next largest loads, which were the drives for the CDUs, for example, we change these to low harmonic, press reselect, and then again press select all. Once that's done, if we click back to the transformer, you can see we've actually come down the size of the transformer again. So the multiplier now is 0.95. So now we've changed some of these bigger loads which are creating the biggest harmonic content. You can see the fundamental power compared to the apparent power is closer, which makes the ratio better. And also a 5,200 kVA transformer. If we click on the network check, we should see now the distortion levels are coming into something a bit more realistic, at least what we would expect. So down to 7% current and 2 point something percent voltage. So it's less than what it was and it's much of an improvement. You can change some other things in here as well in terms of cable lengths and different things like that if you have that data. But this is just a good way to give you an example. You can change the graph data from current to voltage, and you can go primary and secondary side of the transformer as well. So you can also generate a report if you press that button. So there's many things you can do with this, which is quite useful. So this gives a good comparison between what you can do and the difference in sizing that occurs when you're changing drives from 6 pulse to ULH. We can also look at changing some of the smaller ones to get there's a couple of reasons why they might do that. They might want to see if they can size the transformer lower again, or even if they just want to reduce the distortion levels. So if we go to the next biggest, if we change these to low harmonic, click OK, and then select all again. You can see the transformer size hasn't really changed. It's the same as before. The multiplier has improved slightly, and the difference between fundamental power and apparent power is less because there's less harmonic content. The transformer's got 300 kVA reserve as well, so there's a bit of room in the transformer, so it's not sized right close to the limit. If we go into network check, calculate that again, you can see the numbers come down again. So current is less than 5%, voltage down at 2 point something percent. So depending on what levels you're looking to meet, this can be a good way to show and sort of look at a different system based on the actual loads. I think it's most useful for actually showing the effects of on the transformer in that respect. So something useful to show to consulting engineers especially. So let's wrap things up with a summary. So to summarise, access, there's an online version for anyone to access at the web address shown on the initial pages. There's a downloadable version for PC available as well, which you can access through the ABB Library and Download Centre. So Drivesize can be used to select optimal drive system components, so motor, drive, transformer. In that respect, you can size all those. You don't have to size them all. You can just use the motor and select the drive. You can mix and match depending on what you're looking at doing. You can easily save projects offline and send to colleagues or customers so they can review and look at a proposal you put together or some examples which we went through in those exercises to show the differences. Can be used for calculating system harmonics. We went through this on a system for a data center and showed the difference in the network harmonics compared, and obviously as we changed different things, it showed that as well, which leads into creating examples to show the impact harmonics has on transformer sizing. So you can see as we changed the drives from 6 pulse to ULH, with the harmonic content being reduced, the sizing and the D-rate for the transformer became much more favourable. So less D-rate required, smaller transformer, which means less initial cost outlay, which is something you've got to try and explain to people as a total cost of ownership rather than looking at initial cost for one-off products. Look at the system rather than individuals. And finally, this is a good tool to help drive specification with consultants in terms of explaining. Some of the things we talk about sometimes are not that easy to explain with words or maybe just on a slide or two. If we can go through and compare with different examples like we did in this video, it helps a lot in explaining that to consultants.